What's going on, dudes? So for those of you online, I'm going to cut this class a little short. I'm just going to do a little bit of theory and then I'm going to stop the recording. But don't worry, I was actually thinking of you when we came up with this lab. We put all this stuff together. The reason why I'm saying I was thinking about you is because I wanted you guys to be able to do this lab at home, and all of the material that I have, I was able to get from just the store and stuff from the kitchen and from home. I did want to make it look like we actually had a super cool chemistry lab, which we actually do have a super cool chemistry lab. So I put them all inside of chemistry beakers and I labeled them, instead of calling it vinegar, I called it C2H4O2, because technically that's what it is. It's acetic acid. It's vinegar. It's the vinegar. Anyway, this right here is pretty potent stuff. Actually, I'm almost tempted to touch it, even though I've been telling you guys, don't touch it, don't touch it.
I'll touch it, you touch it. Why is
No, don't touch it.
Put it in your hair.
Wait, so touch it?
All right, no, well, I guess.
I think you said touch it.
No, I said don't touch it. Do not touch it.
There's clearly a touch it. Yeah, but you just touched it.
No, but I'm the teacher. Actually, this is kind of burning.
Oh, so touch it.
No, don't touch it. It's hydrogen peroxide, but this is the super concentrated stuff. The stuff you can get at the store is like 1%, and that's the stuff where you pour on it and it fizzles and that kind of stuff. You don't want to be putting this on your sore. It will definitely clean the cut.
Wait, so put it on my
It'll also start to clean your skin, then clean off your skin. Well, I don't think it would do it with this one, but I mean, if you get the even more crazy stuff, then you can actually like disinfect, like, I don't know.
The world.
Yeah. And I don't have the funds to be able to get that stuff for you, but this is the best I could. I got this at Sally's Beauty Supply.
So drink.
Yeah, the next step up, because this is 40 volume, the next step up, 50 volume, I would needed to have my beauty supply license, which I haven't finished that curriculum yet, so I'm still working on my beauty supply license. Can't you tell? All right. There's one concept that I definitely want to cover with you, and it's kind of a review concept. And I'm going to go over it because I felt like when I covered it with Andre, after our discussion on Monday, it felt like you guys were like, oh my goodness, this is weird stuff. So the reaction that we're going to be doing with the sodium bicarbonate and the acetic acid, baking soda and vinegar, is actually going to be teaching you guys about this concept of limiting reagent. But I did want to kind of recover it with you, or kind of tell you guys this is basically what happened. The problem is, remember that cool s'mores lab that we did? We did it, and there was this concept that I really wanted you guys to learn, and I felt like you guys did learn it, but the stuff we did on Monday relates directly back to that. But it was so long ago that you guys were like, I don't even remember what we did back in the s'mores lab. So let me kind of just recap real quick. I think on our s'mores lab we had like two marshmallows and 1 graham cracker and 3 chocolates gave me 1 s'more, right? And maybe I can abbreviate the s'more. And I know I made something clever so it actually spelled out the word s'mores, but I forgot what I did, so I'm just going to put 1 mm2 plus, or 1 mm2 GR CH3. Now it's balanced, right? There's 3 chocolates on that side, 3 chocolates on that side. Are we cool with that? So it takes exactly 2 marshmallows, 1 graham cracker, broken in half, of course, and 3 chocolates to make 1 s'more. And then I'll say something like this: What if I gave you 7 marshmallows, and I gave you 10 graham crackers, and I gave you 15 chocolates? Okay? How many s'mores can you make? Now, before you figure that out, because I know that you guys are thinking, oh, this is so easy, I'm just going to figure it out in my head. Why don't we go through it kind of systematically, all right? Let's do this. Let's start off with 7 marshmallows. If we have 7 marshmallows, that will give us exactly how many s'mores? How many? 3.5. All right, and maybe a good way to do that is to say, well, you need 2 marshmallows for every 1 s'more. This is the same as a s'more. So that gives you 3.5 s'mores. Does that make sense? And then, that's assuming we had unlimited graham crackers and unlimited marshmallow or chocolates, right? I didn't care about how many graham crackers or chocolates I had. I just said if I had 7 marshmallows, I could only create at most 3.5 s'mores. Are we cool with that? All right, what about 10 graham crackers? How many s'mores could I create? Assuming I had a barrel of marshmallows and a vat of chocolate. I could create 10. And you could say 1 graham cracker for every 1 s'more gives you 10 s'mores. Right? And then I do the same over here. So how many s'mores can I create with 15 bars of chocolate or 15 squares of chocolate? You can create 5. So you go 5 chocolates for every, 3 chocolates for every 1 s'more gives you 5 s'mores. But here's the question that I have for you. If I literally only gave you 7 marshmallows, 10 graham crackers, and 15 chocolates, how many s'mores can you actually make? 3.5. And then what's gonna happen? After that, you're gonna be like, well, I could have made 10 s'mores, but how are you gonna make 10 s'mores? Like, some people would say, I could have made 5 s'mores. No, you can't make 5 s'mores. Where are you gonna get the marshmallows? After you've made 3.5 marshmallows or s'mores, you're all out of marshmallows. You can't make any more. Does that make sense? So, which reaction, which product am I actually going to have? I could have this many, I could have this as a product, or I could have this as a product. Which one will I have? I will have the smallest one. Does that make sense? Which is actually what we did on Monday. That's exactly what we did on Monday. And I was trying to justify, I was trying to say, oh, remember back when we were doing all this? And I said, oh, take a look at this and take a look at this, and we have the theoretical yield, and what reaction will actually take place? And I circled the smallest one, and you guys were all like, what the heck are you doing? This is exactly this. The way I go about doing these limiting reactions is I say, if I have this much of something and I have unlimited amounts of everything else, what can I make? And then I go through each thing with that. And then I'd say, okay, now I'm going to choose the smallest one, because I can't make any more beyond the smallest one. I'll just run out of that ingredient completely. Does that make sense to you? So that's what the concept we were covering on Monday, which is why I thought the s'mores lab was such a great lab. The problem is the concept that I actually had to teach you came way after we did the lab. So maybe what I'll do is in the future I'll do that lab later on. To be honest with you, I don't really like the way the textbook covered stoichiometry. We didn't really get into this limiting reaction as much as I wanted to. Are we cool with that? All right, so here's what our lab today is. A part of the lab is Bradley and I were having this huge discussion the other day about why are the precipitation reaction, what the heck is going on? Like, why is there a reaction going to actually happen? You know what I mean? And I was reading this story about, back when I used to go to parties and everything, I would carpool with all my friends, right? This was before I stopped drinking and became a dad and responsible. So I would go to a party and I'd arrive with all of my friends, right? So we'd all go and we'd go into the same car, we'd carpool together, go to this party. And then we'd kind of get to the party and we would disperse, right? And then So I was in a fraternity, and we would go and do that. And then the sororities over there, they would go do the same thing. They'd get to the party, and they would disperse, right? And we'd mingle amongst other people in the party. Now, we didn't always go. Gosh, I'm wondering if I'm going to get in trouble for this story.
Go for it. No, we won't tell.
All right, fine. It's only on recording. We didn't always go home with the same people we came.
Whoa, wait, what? Explain.
Well, does that mean right? Well, what you did is you would go to the party with your friends, right? And then you would disperse once you're at the party. You wouldn't hang out with just your friends. You would go and meet new people, right? And then you'd make new friends, and you'd go carpool with them on the way home. And you'd be like, well, my friends are going to go home early, so I'm going to go with them because, they're pretty and whatnot. Right?
What happens?
I'm
What
sorry, I
reaction
don't-
occurs after that?
Now you guys are wondering, what the heck is he getting at
I
with
don't
this
follow.
with this
I
stuff?
follow.
Yeah. There's these 4 awesome chicks.
Yeah.
Okay, no. All right. Essentially, to me, that's what this precipitation reaction is. You have 2 compounds coming in, and they get dissolved in water. The water breaks them apart, so it's like coming in with you're coming into the party with your carpool, and you go to the party and you kind of split up from all your friends. But then, you could meet back up with the people you came with, or if there's a stronger attraction between you and somebody else who, maybe came in the same route where they both came into the thing, they were in an aqueous solution, and so they got dissolved into their ions.
That's how you begin with that.
Oh my god.
Yeah, I know. And that, my friends, is biology. Okay, no, I'm not covering biology. You don't want me teaching biology. But that would be my precipitation reaction idea. And so I kind of wanted to try a precipitation reaction. In fact, I kind of wanted you guys to do it. So what you guys need to do is take, I have the formula here. So listen to this so that way you guys can make sure. All right, you guys take a, 5 milliliters of alum powder and dissolve it in half a cup of water, 120 milliliters of water. And then I want you to take a pipette and suck out some of this NH3 ammonia and drop it in. Now, what you'll have is you'll have a clear liquid here, and you'll have a clear liquid here. Well, this doesn't look clear, but when you dissolve it in water, it will be clear. And the precipitation reaction that I want you to see is as you drop in this liquid, what should happen is white crystals should start to appear. That's a precipitation reaction. It's because the alum got dissolved into its ions. It was a carpool going to a party, and it got dissolved, and it met up with other cations and anions that are in here, and they kind of hooked up and formed this precipitate. And when a precipitate forms, that's when you know a reaction has happened. What's interesting is I kind of want to try changing, after you see the precipitate, I kind of want to try changing the pH of this thing and seeing if that will dissolve the precipitate back down. Because I'm thinking that if you increase the acidity of this combination, this thing stinks so bad. If you increase the acidity of this combination, then it actually, the acidity changes the ability for salts to dissolve. So I'm wondering if you'll be able to redissolve it. The next thing we're going to do is sodium bicarbonate and C2H4O2 vinegar. And we're going to take some test tubes and water balloons. We're going to fill up the water balloon with different amounts of sodium bicarbonate, baking soda, and we're going to try to take the baking soda, put it in the vinegar, cap the test tube off with a balloon, and then see how much the balloon inflates. What I'm thinking is, well, maybe we'll formulate the hypothesis now. Would putting more baking, so what we're going to do is we're going to have 6 test tubes, and we're going to have increasing more baking soda that we would add to the same amount of vinegar. If I have only a little bit of baking soda, will a reaction happen? Sure. If I have more baking soda, will it happen more? Sure. If I keep adding baking soda, will it always just get bigger and bigger and bigger? What's your thoughts?
Only if you increase.
Why are you shaking your head?
Because
Yeah, shake.
compared to the powder,
What is that?
because liquid is not going to dissolve the powder when the powder is.
Oh, if the powder is too much, the liquid won't be
Yeah.
enough to dissolve it. You might have a limiting reaction happening there. A limiting reagent, huh? Okay, yeah, exactly. And that's the way I wanted to teach that concept. All right, the next lab we're going to do is elephant toothpaste. The directions are here. The idea behind this is a little bit of stoichiometry that I want you guys to be able to do, and I think it's also a cool reaction. I want to light it on fire because I think that's a lot of fun too. And here's what we're going to do. We're going to do the one where you follow this recipe exactly, and then I will let you guys free reign it and mix whatever it is you want and see who can make the most amount of product. The hard part, I think, is measuring how much reaction you get, right?
You're a lot of things.
Because one could be like, hey, it could give you a lot. It just goes really slow and boring. And maybe another one could be like, it only gives you a little bit, but it goes and it hits the roof and all of that kind of stuff, and that'd be cool. I got as high of a concentration of hydrogen peroxide as I could. Anyway, any questions? Comments, concerns?
Eyebrows, will you then get your license?
If I what?
If we lose our eyebrows.
Will I get my beauty license? No, you won't lose your eyebrows. You'll just have yellow eyebrows after this, and you'll lose your sight. So speaking of that, actually, everyone in this lab has to wear goggles. I will require that,
There you go.
I can rock a pair of goggles.
and glasses don't count. Of course, none of you guys are wearing glasses. I'm the only nerd who's truly wearing glasses here. So Oh, no, there we go. glasses don't count. You still have to wear goggles over the glasses because the goggles will protect the sides and it's still. If this gets in your eyes, I'd imagine that it would disinfect your eye, which is not a good thing, right? All right.
I went to my eye doctor on Monday.
So.
That's probably the worst thing that
Yeah.
What, hydrogen peroxide in your eye?
Yeah, he said that's one of the high.
Yeah, and this is like 12% compared to the 1% that you get at Walmart. So.
Why don't we have 100%?
100% hydrogen peroxide would probably
Burn.
melt your face.
Yeah.
All right, anyway. I don't even think that chemists have access to 100% hydrogen peroxide. I mean, I'm sure they do. I'm sure they could make it. All right, any questions, comments, concerns, vomits, etc.? And then for those of you online, I apologize. I'm not going to be able to run this lab online and here, so I'm just going to stop the video recording. I wanted you guys to see this concept. We cool? All right, let's have